Lecture is on, I call it uh, information, the basis for life. In other words, life could not be without information. The only difference between life and dead material is information, and information is required for life. That is the basic message that we want to convey here. So again, this lecture will be is being recorded and will be captured on my website when it's finished. Okay. So I'm going to step through these slides now. And as I said, the title is Information, the Basis for Life. So what we're going to cover is these 10 topics. First of all, how do we view life? Did life get here through creation, as the Bible tells us, or as some secular science would say, no, we got here through the process of evolution. And we're going to see, is that even possible? So as I go through these lectures, I will make comments on that. So second is the what's the difference between things happening by chance or happening by some law of nature? It might require that to come that way, or design. In other words, was life designed? So next, what assumptions do we have when we talk about this topic? And presupposition is just another word for assumptions. What assumptions do we make what assumptions do we expect to be true in order for life to come to be? So we're going to talk about the nature of information. What do we mean by that word information? And one way to think about it is I am speaking sentences in English here, and you are listening to sentences in English there, and you can understand them because they're in a common language that we both understand. But if I was speaking in a different language, what I was speaking would not be understandable to you. So information is something that we can share and transmit. And the fifth thing I want to talk about is machines. What machines are involved? You will be surprised when you see that there are actually machines in our bodies as well that make life possible. And then want to talk about programs. And when you talk about computers, you know what I mean by a program. I can write a program in a language that the computer understands, and these programs are possible to run on computers. But in our bodies, there are also machines and programs that process information. And so we want to see how they're related. So number 7, life requires information. But what about that information? What is it? And you will see that the information is very complicated. It's very complex. And it could not happen without design. It does not happen from random chance processes. Information can only be designed and to be understood. A random information, random data is not understandable. And then we'll talk about again the concept of mathematical probability. In other words, we can talk about what's the probability of life happening by chance. And you will see as we get into this that that is not possible. Then the next is life from non-life by chance. It could have gotten here by chance. It could have gotten here because of a law of nature, or somebody designed what life is. and then we'll draw conclusions. Okay, so this is the things we're going to walk through. So first, I want to talk a little bit about the different views of life. Okay, some people and we as believers, we think God created life, and as explained in the first chapter of Genesis. But there are others who think that life happened just by chance. Okay, so the biblical view of life is, as it says in the Bible, God created life. God created every living being. And in the chapter 1 of Genesis, you know these verses very well. Plants, like herbs, they yield seed according to its kind. So different kind of trees, different kind of grass, they all were created by God as different kinds of plants. And these plants can duplicate, they can replicate, they can reproduce um, but they reproduce according to their kind. One kind of seed from a tree doesn't, when it's planted, doesn't produce another kind of tree. It produces another tree according to its kind. So life indicates stability. There's a stability of kinds. And by kinds, we mean things like this picture here with dogs. We all may have different kinds or different types of dogs. A small dog, a big dog, a wolf. These are all part of the I'm sorry, of the dog kind. We also have the cat kind, we have the cow kind, and we have mankind as God identifies us in the Bible. So the point of kinds is that everything is reproduced after its kind. Okay, you may have different types of dogs, but they're all related. But in the reproduction of dogs, dogs will not produce cats or other animals of different kinds. They can only produce after their own kind, and that's what we mean by kinds. Okay, biogenesis, that's the start of life, each producing after its own kind. That word kind is used 10 times in the first chapter of Genesis. So I think it's very clear how God explains to us how life came to be. And you'll be familiar, you'll see these pictures here. For it is in the life of all flesh, the blood of it for the life thereof. Therefore I said to the children of Israel, Leviticus chapter 17, verse 14. So there is blood in our veins, and that is what life is. I mean, life couldn't exist without blood. And you'll see in the mother's womb, babies start out as one cell, and then they duplicate into similar cells. And then eventually you'll see the formation of a baby as it goes through different stages. Okay, and then eventually that baby is born. And how does that happen? Well, it's life starts out with a sperm and an egg get together into one cell, and then the cell starts to duplicate itself. So these cells duplicate, um, and they are identical in the first duplications, and then they duplicate. One becomes two, two becomes four, four becomes eight, eight becomes 16, and so on. They keep on duplicating, and they're all the same cell, but the same kind of cell. So our body has about 200 different kinds of cells. So somewhere during this duplication, these cells starts to differentiate, into skin cells, eye um, cells, and different kinds of bones and all that. 200 different kinds of cells in our bodies. How did that happen? There must be a program in that first cell that knows exactly when to start duplicating similar cells and duplicating different cells. So, and again, you know these verses very well. In Psalm 139, verses 13 to 14, you knit me together in my mother's womb. I praise you because I am fearfully and wonderfully made. Okay. Jeremiah 1:5, before I formed you in the womb, I knew you. That's from God speaking in the Bible. So that's what we mean by different kinds. Okay. And that's how life is. So then, but evolution has a very different view. This is the evolution view of life. First of all, evolution would say everything is related through common ancestry. In other words, life started out as one cell. They would agree. You can look at this Darwin's tree of life. Okay, starting with one cell, and then well, a simple life, and then life becomes more complex, and the life starts to differentiate. Okay, and then different branches of the tree, different kinds of life. How does that happen? Can that happen through evolution? And so you'll recognize Darwin here, and here's you may have heard of this man, Richard Dawkins. He's a biologist from the UK, and he believes in evolution. Okay, and what is evolution? Well, from the origin of the universe, we get the origin of Earth, or some kind of primordial soup, and then we go to RNA world, protein world, DNA, the first living cells, bacteria, primitive animals, fish, amphibians, reptiles, mammals, lower primates, monkeys, early apes, hominids, and then humans. That's us. Evolution will say that's how life started from the beginning, and it results in us. Okay, so the three big points about evolution is all life is related through common ancestry. By common ancestry, that means that every living being started from the first living cell. And then different living beings came through mutations. That is, some of the information in our cells mutate, and then natural selection occurs to choose the kinds of cells that survive. Okay, and so all this is by means of random chance processes of nature. So there's a very big difference between evolution and creation as recorded in the Bible. So they can't both be true. Okay, then you may remember I used this slide a number of times. That what it says really is that everything comes about through one of three causes. Otherwise, it happens by chance. You know, we can't predict what's going to happen. It happens because there's a law of nature, which means it's going to happen that way. But if it's not one of these two, then it must be design. And design, as we've discussed before, requires a designer. There must be an intelligent agent that caused this to happen. So if you look at this picture of the faces of four of our presidents in the US here on this rock on a mountain, okay, you'll see the pictures of four different presidents. And of course, you know, we would recognize this as George Washington. And the face looks like George Washington looked when he was alive. So did these faces, these four faces, did they happen by chance? In other words, maybe the rain came down on the rocks and it carved out these images that you see here. No, I don't think so. What about a law of nature? Is there a law of nature that would cause these images to appear on the rock? No, there's no way that could happen. well, I think we all agree that there was a designer, an artist who had a picture of these four presidents, and there's craftsmen who carved these images into the rock, each one of them. So that means there's a design involved. There's a designer. Who was that designer? Well, there was some artist who did that. So in other words, there's design, there's information involved in these faces. Okay, so then what are we talking about when we talk about life? Well, life is very complex. What are in our cells? The living cells requirements. You have here a picture of a cell. This is one of our cells in our bodies, and it's very complicated. You can see it has chromosomes, it has a nucleus, it has, it has a um, this film around the whole cell because we're looking inside the cell here, but the real cell is covered by this membrane. There's a membrane which covers the whole cell. And so without that membrane, that cell could not live. There's fluid in the cells, there's machines in there, as we'll see. So it's a very complicated. This is just one cell. And we have, some people would say about 50 trillion of these cells in our bodies. So life is very, very complicated. And when we get down to the small parts, you'll see that there's DNA. I'm sure you've heard of the word of DNA before, but that's where the information lives in our cells. So the DNA is required of base pairs, you'll see here together, and there's a double helix. Okay, so it's very complicated and very special how that's designed. And then there are amino acids which are in that DNA. And basically there's four of these amino acids, these adenine, thymine, cytosine, and guanine. Okay, and these two of these form base pairs. And so these base pairs, we talk about 3 billion different base pairs in our bodies. So our bodies are very, very complex. So what do we have in a living cell? We have proteins. Our cells have proteins. Each protein is a chain of amino acids. Okay, these are the amino acids there. So there's change of those that make up the proteins. And then there's the DNA, this here. So it's the double helix, and it contains the master genetic code, and there's information in that DNA that describes how the cell works, how the cells in our bodies work. So DNA, I'm sure you've heard of that phrase, but that's what we mean by that. And then there's also an RNA, which is like DNA, but it is ribonucleic rather than nucleic here. So different kinds of acids. The DNA is more complex, it's double helix. The RNA is a single strand, and it has instructions for how to build proteins. Okay, proteins are made of these amino acids, and the RNA describes how they are built using instructions in the RNA. Okay, and then there's catalyst for transcription, transcribing RNA into DNA. There are catalysts. In other words, there are enzymes involved in the reproduction process. So there's, and all this is part of the replication or the reproduction of the cells. And it's very important that there be a cell membrane holding everything together, because without that, anything could get into the cells and destroy the cells. So we have a cell membrane around each of the cells. So you can see again, this is very, very complicated. You need RNA to produce the proteins, and you need a program in the DNA to make that happen. So this, what we say here, is it's a chicken and egg problem. And you might have heard this explained before, where we have chickens and we have eggs. Uh, where do eggs come from? Well, they come from a chicken. Uh, where does the chicken come from? Well, it comes from the egg. I mean, the egg is hatched and produces a chicken. So the question is, which one came first? Okay. And that's what life is all about. I mean, how did this life come to be? There's information required. And in the case of thinking of a chicken and an egg, if you can have an egg, but if it's not fertilized, it's not going to produce a chicken. And you can have um, an egg, but who produces that chicken? It's that egg. That's the chicken. So we say here we have a chicken and egg problem. How did that come to be without a designer? So then we get down again to this discussing these three concepts of how everything comes to be. So everything happens either by chance, necessity, or design. So here we have, look at this first picture here. We have, this is a cave, and then we have scratches on the wall of the cave. How do those scratches come to be? Well, you might say, well, somebody took a rock and put those scratches in the wall. Or it could say, well, the cave ceiling, maybe small rocks came down randomly and they just cut these uh, these trails in the cave wall. Okay, that's not very determinate. But if you look at this cave wall here, and here you see pictures of the heads of horses, the heads of pigs, the heads of cows, and different animals uh, carved into the wall of that cave. Did these happen by chance? I don't think so. They didn't happen by chance. Was there a law of nature which caused them to happen? No, we know of no law of nature that could cause that to happen. So in other words, we believe there was a designer behind that. There's somebody came into the cave and scratched out those pictures of the animal heads in there. So then so that can be described, people understand that. And then, but if you look at uh, the body, our human genome, we have 3 billion base pairs in there in our body. Very, very complicated. Uh, could that happen by chance? I don't think so. Was there a law of nature which uh, caused that to happen? No, there's a design involved. Somebody designed that. So we have about 75 trillion cells in our bodies, and that's all part of our human genome. Did that happen by chance? No, that could not have happened by chance. So then, how do evolutionists explain that? Okay, well, here we'll take three different evolutionists. Here's one that says, uh, uh, Dr. Todd, he's a professor at a university here in Kansas. He said, even if all the data point to an intelligent designer, okay, such a hypothesis is excluded from science because it is not naturalistic. In other words, they don't accept our explanation of that because it's not science. Our explanation is not science, they would say. And even Dr. Richard Dawkins, professor at Oxford University, he would say, biology is a study of complicated things that have the appearance of having been designed for a purpose. Okay, so he will not admit that God exists and that God created life. He said, yes, it looks like it's very complicated and somebody designed it for a purpose, but he can't accept that. And similar with Francis Crick, one of the co-discoverers of the DNA structure back in 1953. He says, biologists must constantly keep in mind that what they see was not designed, but rather evolved. In other words, he can only accept evolution, although he has no idea how that might have happened, because they cannot accept that God exists and that God was the designer of life. Okay, well, then we get into how do we explain this? Well, we have presuppositions or assumptions, think of them as assumptions, and we have information. Information is required for life because the DNA, is has the information and the programs which describe how life is built and how it's duplicated, replicated, and reproduced. So evolutionists presuppose, that there's only two things that are in the universe that make everything happen. There's mass and there's energy. And you may have heard of Einstein's laws, which says E equal mc squared. In other words, energy equals mass times the speed of light squared. That's the equation, which means you can transform mass into energy, or you can untransform energy back into mass. Okay, that's a law of nature. Okay, we all agree that can happen, but there is more. Life is not just mass and energy. Life also consists of information, and the information that we're talking about here is non-material. In other words, mass and energy are things you can touch and see them do things, but information is non-material. It's a non-material entity, but all three of these are required for life, as we'll see. So life consists of mass plus energy, which is material, plus information, which is non-material. So information in life is encoded in the DNA of all plant and animal cells. It's not just for animals, but it's also for plants. So the information is in the plant, information is in the animal for all life. So now I'm going to get into an explanation of what do we mean by information. Well, I'm going to explain it in terms of 4 words. There's some code that's involved here. And if you put certain codes together, you have meaning. And you put that meaning of, like in case of a sentence in English, there's code, there's letters on the alphabet, there's meaning. You can put those letters together and form a meaningful word. And you can put those words into a sentence, and the sentence expresses some activity. And then all 3 of those together, the sentence has a purpose. So think of it in that there's 4 parts. And so these 4 parts apply to sentences that we can make up, but it also applies to life. And this is how we'll take a look at that. So the nature of information first. What do we need? Well, in terms of writing, remember in the days when you used to use ink and a pen to write. Now, if you had a bottle of ink and somehow it spilled over, what does it look like? It looks like a big mess. Okay, there's nothing you can discern here. There's no letters that make any sense. It's just a random, a spill of ink. But if I use that ink with a pen, I can write a sentence with that. Okay. This, of course, this is written in script, and I'm sure you're familiar with script. In some modern societies, we don't think of script anymore. We think of the letters that we write. Um, so anyway, but if you can read script, you can read these words. Okay, so there's ink and words that come here. What's in those words? Well, the letters of the alphabet, and as you know, there's 26 letters in our English alphabet. And so you can put these letters together to make a word that you can understand. And you can take the words and put them together and come up with a sentence that makes sense. So if you come up to the ocean shore someplace in the sand and you see, these letters, WRITE, NIN. These are all words that you understand in the English language, and then sand, SAND. You know what those words mean. And so then the question is, did that happen because it's the way the waves rolled up from the ocean over the sand and then back into the ocean, and it left these letters. Did it happen that way by random chance waves? No, didn't happen that way. Um, was there some law of nature that would cause these letters to be written in the sand in this way? No. Somebody wrote those letters in the sand, and that's we come back to design. Okay. So we take letters, which are the code. We form words, putting some of these letters together. That's meaning. You can understand this word, and then you put the words together and you have a sentence. And that is the third part of information. And then what we know what that means, writing in sand, we know what that sentence means. Okay, so that's the there. So now I'm going to go into a more formal definition here. Okay, those four words, code, meaning, action, purpose. So code consists of, like in the English language, the alphabet, the letters in the alphabet, or in the case of life DNA, there are codes in the DNA. You put those together, you can form something that has meaning. So then meaning, in the case of the alphabet, we have words. In the case of DNA, we have what we call codons. And then we have an expected action. Okay, what's a practical use of putting those words together? In the case of English, you have, you're writing some words in English, you can form a sentence that makes sense. And then what's the purpose of that sentence? Okay, that's where the design comes in and the result comes in. So those four parts in terms of writing, I think you can understand. So, but also understand that all these structural attributes are non-material. Okay. Yes, you need a medium to store those words, on a piece of paper or something like that. But the contents is non-material, as I'll explain here in a bit. So information then, using these four words, information is an encoded, the code here, symbolically represented, and you have a message conveying expected action and a purpose. Okay, so encoded, a code, and putting the codes together, you have a message which can be understood. That's in case of words, and the words come together and they form an action and then a purpose of all that. Okay, so that's what we mean by those four words there. That is information. So let's look a little further. If we look at, again, at writing, and we're going to use the English language because we all understand the English language. You can say we need letters, words, sentences, and we need people that write those letters. So what do we mean by information in writing? Information requires code. And in the case of the English language, we have letters in the alphabet and we have numbers. And we could have some other non-numerical information as well. So we can put that together, the code, into words that have some meanings. And we can put the words in a sentence, and if it has a verb, we can write a sentence that has meanings. And the sentence has a purpose, either a result or design. But there's a designer. We can write sentences, so we are the designer of those sentences that we write. So again, keep that in mind. Information requires these four things to convey information in the English language, and we need these four things. So then we have, again, we need to think about how complex or explain the two words complex and unspecified. We can specify words and sentences, but are they understandable? For example, if I take these letters, you know what these letters are in the alphabet, the N, the E, O, J, C, T. Okay, those are letters that you understand. That's code. But if you look at this here, you don't understand, I don't understand what meaning that word has. Okay, in other words, it's unspecified. That word has no meaning in any language that I know of. And you got other words here which mean nothing in the English language, or I would submit in any other language known. So yes, these are complex. This information is complex, but it's unspecified. In other words, you can't read that. I mean, it doesn't, not written to any code. Then we come to specified complexity. Okay. Now, if I write words out, I specified these words. Okay, you can understand what those words are. THE is the, a cow, COW. Okay, you know what these letters are, and you know the letters are put in some specified order, not in unspecified order, but in specified order. And because they are in a certain specified order, you can understand what these words are. JUMPED is jumped. Okay, and then over, OVER, the moon, MOON. So this sentence has coded letters. It has words that have meaning, and this sentence, putting these words together, specifies an action. And here, of course, we have a picture of the cow jumping over the moon. This is not a real um, thing that happens, but that sentence, you know what that means. Okay, so just to summarize, then, the difference between this sequence of letters and this, we can understand the words here. So this is meaningful information. I can speak this sentence, you know what I mean. Okay, but this here, if I give these letters and these words and this sentence to you, you have no idea. Okay, because the letters are the letters are understandable, but the words have no meaning. So it's unspecified, but it is complex. Okay, this is a complex sequence of words. It doesn't happen by chance. And this is a complex sequence of letters and words. So it is complex, but it is specified. We understand what that means. So then we go to the computer, and some of you may have dealt with computers and programming. How is information stored in computers? Well, it's stored by zeros and ones, okay, on a disk. So you have a disk in your computer. You even have machinery in your phone. You have a smartphone. Your smartphone has information, and the information is stored in zeros and ones. And the order in which the zeros and ones are stored provides meaning. So here, for example, you can write a program, and we call this pseudocode because there has to be somebody that can understand this in the computer and then turn it into zeros and ones for the program. So the zeros and ones are the code in the sentences. So here we have some code which some of you may be able to understand, but here the pseudocode says number equals input number, result equal number %2. In other words, it's determining whether it's a 0 or a 1. And if the result is 0, then print the number is an even number, else print the number is an odd number. So this is a program that can be executed. And so we have the code, we have the sentences, and we have the words in the sentence, we have the sentence, but that doesn't happen without a programmer. Somebody programmed that code. And we have computer programmers. I used to write code for computers, and this is you got to write that in the computer, put it in the computer, put it on the disk, and then you can execute that program and see the results of executing that program. So this is how information is handled in computers. So we have information in writing, we have information in computers. How about living systems? Okay, we have information in living systems too. So we have DNA, which stores information, the base pairs, and that makes up the proteins, for example. So the code, consists of just the 4 letters, A, T, C, G. And you'll see they can be put together in meaningful categories. And this is what it looks like if you were to print out what's in the computer, you could get something like this. So you have base pairs, and the A and T always fit together, C and G always fit together. But it's the order of these base pairs that determines what it is. Okay, then we have the DNA. Okay, so that we have DNA is a molecule of life. There are trillions of cells in our body. Each cell has 46 human chromosomes, 2 meters long of DNA. If you stretch this DNA out over a distance, it would be very, very long. And you have 3 billion of these DNA subunits with these base pairs, A, T, and CG. We have approximately 30,000 genes that code for proteins that perform most of life's functions. So this is these are the programs that are in our cells. And as you can see, life is very, very complicated. And this is what, we showed you a picture of the shell before. Okay, so these are very, very complicated. And, the membrane, as I said, is very important. It has to be there for it to work. So, okay, so now we've covered information. Then we have to talk about machines, because machines are involved in all of this. If I showed you this picture here, you can say, well, that's a plant where cars are made. Cars are on as what we call the assembly line. And at each point on the assembly line, different parts of the car are put in place. And so that's how the car is constructed in the assembly line. That assembly line is very complicated. How you pick up the parts and put them together into a car. That doesn't happen by chance, you'll agree. And then what's in the car? Well, one of the components is a motor, an engine, that which in itself is also very complex. But that motor has to be put in the car, at a certain point in the assembly line. And then we have here is a simpler part of this motor here. You're going to have parts like this, which have rotors and which have screw holes to tie things together. So this is a simple electric motor, but it has all kinds of parts and all kinds of connections to other parts of the engine. And then we have a computer. Computer is very complex in itself. It has transistors. It has integrated circuits, and it has circuit boards, which are all the pieces are put together. And it has connectors. It has a box where it's stored in. Has lights that come on in the front of the computer. Has a disk and sometimes even a fan. And all these parts put together make up a computer. Okay, that's a computer machine. This is the car machine. Each of them are constructed from parts, many, many parts. And so how do they all fit together? They're not going to fit together by random chance processes. Somebody designed that assembly line, somebody designed the car, and described how to put all the pieces together. And the same thing for a computer. You have to know how to construct a computer. There's a program or there's a design of this computer. Somebody designed that. So that we look at, so that was, machines that you're familiar with. But what you probably don't know about is there are actually machines in your body as well. There are molecular machines, and these are, they can be motors, okay, which look like this. You can recognize the gears and the rings, in mechanical parts, but we also have these kinds of motors in our cells. Very, very small. Of course, you can't feel them, but when you have a microscope, you can see them. Okay. So here's the parts of the motor. And so we have molecular machines here. But the point I want to make here is that how do these machines come to be? If I pulled out one of these parts, of this machine here, it wouldn't work anymore. And the way to understand that is that there's a intelligent design person called Behe who showed that all these pieces are what he says irreducibly complex. Now, those are some hard words. How do I explain that? Well, that means all the parts are there, but all the parts need to be there for that motor to function. In other words, this motor will not run if I take one of the pieces out. Okay, and so in terms of life, in terms of if you were to think about evolution, all the parts need to be there for evolution to even work. So how do we explain this term, irreducibly complex? Well, Behe described that in terms of what he calls Darwin's black box. So I'm going to explain this in terms of irreducible complexity over here. So there are over 100 molecular motors that are now known to exist inside the cell with very specific analogies to human designed motors, but they're very complex. So what do we mean by this irreducibly complex? that means all parts need to be there. Think of a mousetrap. You know, how does the mousetrap work? Well, it requires 5 different things. It requires a board, a base. It requires a hammer, this hammer here. It requires a catch here. It requires a spring that is needed, and a holding bar here. So there are 5 parts for these mousetrap. And so you pull back this spring and lock it into with a hammer or here into this catch, and then the hammer will come down on the mouse if it touches one of these parts. So this mousetrap will catch mice with all of these parts. What if I took one of these parts out? Would it catch any mice? No, it would catch no mice. Well, so what that means is that all 5 parts need to be there, okay, for the mousetrap to work. So that's what that means. All parts need to be there to be functional. Okay, if you look at the motor here, all these parts need to be there for it to work. So that's what we mean by this irreducibly complex. In other words, irreducible, you can't get less parts than 5 in a mousetrap for it to work. And you can't get less than a few hundred parts in a machine here, in a molecular machine for it to work. Okay, so that's what we mean by machines, and that's what we mean by information. Now here's
Germs in your intestines have sophisticated machines inside of them. Like all living things, E. coli bacteria contain DNA, which requires sophisticated machinery to read the DNA and turn the information into proteins, which are the major components of all living things. One of the key machines involved is the ribosome. According to the world's leading science journal, Nature, the ribosome, together with its accessories, is probably the most sophisticated machine ever made. All of its components are active and moving, and it is environmentally friendly. Ribosomes, however, are not just stunning examples of nanotechnology. They also seriously undermine the idea that life arose spontaneously. Life is not possible without ribosomes. So, if a hypothetical first living cell arose spontaneously, this means ribosomes must have arisen spontaneously also. Call me a skeptic if you like, but the idea that sophisticated machines can arise without a designer sounds like a fairy tale.
To find out more from Creation Ministries International, visit our website, creation.com.
So that gives you a quick look at the ribosome, which is needed, to produce something inside the cell. So this is a very sophisticated machine, and that machine did not happen by chance. That was designed. Okay, then we look at the nature of programs. We looked at information, we looked at machines, and now we look at programs. Okay. And if we look at, in case of a computer program, your computer, it's a physical item here, but in the computer, there's an operating system. You have a monitor, and there's a display that you can see, and you can manage the disk and the files on the disk. So that looks like this in this picture. You got the hardware, the CPU, and the disks that store the information. You got a mouse, a printer, etc. That's all the hardware. And then the software, the system software, is the operating system of the computer. Like Windows is the operating system for a lot of PCs. And then on the operating system, you have different application software, word processors like Microsoft Word, you have databases, you have spreadsheets, computer games even, and internet browser. These are all application software programs that run on top of this system, operating system. And then you have, programs. This happens to be a program written in a language called Java. we're not going to go through this, but you can see that these are programs that are deciphered by the computer software into executable code on your computer. So that this is a program, but you need something to run that program, and so you need hardware and software to run that program. So then, what about in the cell? The living cell. You'll see these words come back again. You see the DNA, the RNA. You see transcription. Okay, you see the ribosome. Okay, where things happen. So there's a translation process that goes on to produce a protein. Those instructions come from the DNA, which is transcribed into the RNA, and then that is executed in the ribosome to produce a protein, which is part of your living system. So that's what the replication is involved. That's where there's a program in the cell which makes this happen. And you'll see more here. Another way to show it, the DNA molecule, the genes, and the DNA transcription into the mRNA, and that produces proteins. But proteins are required to run this machine as well. So you have a chicken and egg problem here. And then you got the amino acids, which make up the proteins. Okay, so looking at this human DNA is like a computer. There's a program in your cells, in the billions, trillions of cells in our body. There are programs in there. So the human DNA is like a computer. But this computer program is by far, far more advanced, more complicated than any software we've ever created. Who said that? That's Bill Gates, the founder of the Microsoft company. He realizes that the programs in our cells are much more complicated than the computer programs that he and his people have written in your computer. So what's in our body is much more complicated than what's in your computer. So then life is complicated, okay, but life requires information, complexity, and design. Okay, but it's very important to have all of these. So DNA, it consists of base pairs. These letters A, T, and C, G, codons 20 left-handed amino acids. Okay, biological systems exhibit what we call specified complexity. Remember that picture where I showed specified complexity in a sentence? Okay. So biological systems exhibit specified complexity and use irreducibly complex parts. In other words, all the parts need to be there to work. Okay, you can't just have a few of the parts, you need all of the parts to work. So the naturalistic mechanisms or undirected causes do not suffice to explain the origin of complexity. Intelligent design constitutes the best explanation for the origin of specified complexity and irreducible complexity in biological systems. Okay. Okay, so a little bit more information on life. Now we're going to come back to the code, the meaning, and those four parts. So first of all, the code here, we have four letters, A, C, G, and T. In the DNA, we have words called codons composed of three of these letters. We have meaning. Each three-letter word represents one of the 20 amino acids that are necessary for protein formation. Okay, proteins are necessary for life. The sequence of codons in the DNA represents the sequence of amino acids in a protein. So again, we're going through code, we have meaning. You put these letters together and you have a meaningful codon, and then you have an action. The proteins are needed for construction, function, maintenance, reproduction of the organism and its cellular components. So we have three parts of the information, and then the purpose. What's the purpose of all this? In our bodies, it's reproduction of life. Okay, so you see the information in the English sentence, and here you see the information in our cells, the DNA. Complexity of the cell, well, we've seen this picture a number of times now. We got, and our bodies contain about 75 million of those parts. So then, going back to this chance, law, and design. So you start here. You ask the question: is this what we see happen? Is this highly probable? Yes, it could be a law of nature that requires it to happen. This is what they call an explanatory filter. How do we explain what we see here? Okay, so there's an intermediate probability, then it's by chance. In other words, sometimes it happens, sometimes it doesn't. Then you have specified probability, small probability, and if it's a very small probability, it just can't happen by chance, and it can't happen by law, it can't happen by chance, then it must be designed. Okay, so that's how we end up with that. So then what's the evidence for design in life? Well, in biology, the presence of complex and functionally integrated machines has cast doubt on the Darwinian mechanisms of self-assembly. Darwin cannot explain this. Evolutionists cannot explain this. Molecular biology, the presence of information, we saw the information in the DNA, is encoded along the DNA molecule, has suggested the activity of a prior designing intelligence. So here, Harvard professor Lourdes Lewontin says, he urges scientists to embrace a materialism that is absolute and to stick with material explanations, no matter how counterintuitive. In other words, he's saying, don't consider design, just consider evolution. But as we see, evolution cannot explain how life came to be and how it operates.
We've shown that DNA is actually the software of life that's totally interchangeable between the digital world and the biological world.
The DNA code itself is so digital, is so almost exactly like a computer tape.
Interchangeable. So it's software of life.
Scientists have come to the amazing conclusion that our bodies contain digital code. In fact, Bill Gates, the founder of Microsoft, tweeted, DNA is more advanced than any software ever created. Think about it. A program or code is written by someone very smart. The more complex the code, the more intelligent the author has to be. So here's the question. If our DNA code is more complex than any man-made software, where did it come from? Is it possible it was authored without an author, programmed without a program? Materialists think so, through neo-Darwinism, the modern version of Darwinian evolution. Stephen Meyer, author of the New York Times bestseller, Darwin's Doubt, explains.
According to neo-Darwinism, new genetic information arises as a result of random mutations in the arrangement of the nucleotide bases along the spine of the DNA molecule. If those
Okay, well, there you have it. I think those scientists explain that life cannot happen by chance, and life does not happen because of some law of nature. It happens because there was a designer behind it. So now I just want to review a few things about mathematical probability. I'm sure, if you have a coin that has a head on it and it has a tail on the other side of it, something like this, a head or a tail on the other side, what's the chances of getting all heads in a row when flipping a coin? What if I, flip a coin, I get a head. Flip a coin, I get a head. By chance, normally you would get the same number showing heads and tails. And so the chance of flipping multiple heads in a row, what's the probability? One head in a row, two heads, three heads, 10, 100, 1,000. The chance of each of these, you go across here, one and a half. In others, you'd expect to get a head half the time and a tail the other half time. So as you get more, you throw more and more, the chance of getting, 10 heads in a row is 1 in 10 to the power of 3. That 1 in 1,000. And then, but as you go up to 100 and then to 1,000, you got 1 in 10 to the power of 300. Now, this number, if it's greater than 50, the chance of that happening by chance is 0. Less than 50, greater than 50 here is it's not going to happen. The probability is 0. That's the law of probability. Less than 1 in 10 to the 50th is mathematically impossible. So let's look at some probabilities here. Here's a plane. It consists of about 5 million parts, non-flying parts. What's the probability if you had all those parts, the 5 million parts, in a junkyard, and you had some kind of an explosion and they all came together to make an airplane that flew? It's not going to happen. Okay. The probability of monkeys typing away at a typewriter, could it produce a Shakespearean play? Not going to happen. So then we ask the question, what's the probability of a protein coming into being by chance? Well, here's a protein which consists of hundreds of amino acids. Proteins and amino acids, there are a few thousand types of amino acids in the world, but they come in right-handed, just like our hands. We have a right hand and you have a left hand, and they come in right-handed and left-handed forms. But the proteins, the building blocks of life, they require these aminos in a row, in a sequence. So large organic molecule contains hundreds to a few 10,000 amino acids in a sequence, specified long sequence of amino acids. There's only 20 left-handed amino acids that make up life, but they have to be put in a very specific order in order to produce a working protein. So what's the probability of that? The crucial protein fact, the absence, addition, or replacement of a single amino acid in the structure of a protein causes the protein to be useless. It's not a protein that would work. So it has to be exactly the right sequence. What's the probability of getting exactly the right sequence? Well, if you take 200 parts and line them up in a specific order, there are mathematically 200 factorial ways of doing that. But I'm not going to take you through all the math here, but for those mathematicians, you can understand what I'm doing here. But the net result is there are only 10 to the power of 80 atoms in the whole universe. Anything less than 1 in 10 to the 50th is regarded as mathematically 0 probability. It's not going to happen. Okay, we see here just one protein, 200 parts, the probability is 1 in 10 to the power of 375. But that's 375 is much, much greater than 50. So it's just mathematically impossible. So living organisms contain many more than just 200 parts, because our human genome contains 75 plus or minus trillion cells. So how simple can life be? Well, scientists now know that the smallest bacteria consists of 482 genes, 600 types of proteins, and 580,000 DNA base pairs, letters. The probability of this happening by chance, these forming by chance, is zero. It's not going to happen. Now, Darwin in his day, of course, could not see the complexity of the cell, but now we have electron microscopes. We can see all the way down to the DNA, the small molecule and atom. The special microscopes can see that. So now we know a whole lot more about life. So this cannot happen by chance. The human genome has 25,000 genes, not just 482, 100,000 types of proteins, not just 600, and 3 billion DNA base pairs. So if this can't happen by chance, the human genome is not going to happen by chance either. So if you look at the probability, a single protein with 400 amino acids, the probability of 1 in 10 to the 240, which cannot happen. A single cell is, the probability of getting that is 1 in 10 to the power of 40,000. It's not going to happen. Spontaneous, not going to happen. This is only 10 to the power of 80 atoms in the universe. So the law of probability, 1 in 10 to the power of 50 is not going to happen. So life is not going to happen by chance. So here's what some evolutionists have to say. They know all this today. Darwin didn't know this, but we know this today. Paul Davies, an Australian astrobiologist, evolutionist, is a shame there are precious few hard facts when it comes to the origin of life. We have a rough idea when it began on Earth and some interesting theories about where, but the how part has everybody stumped. Nobody knows how a mixture of lifeless chemicals spontaneously organize themselves into the first living cell. Okay, so he admits, he's an evolutionist, he admits there's no way we can explain this, but they refuse to accept God as the designer of life. Now here's a German information scientist, he's the creationist, Werner Giff. He says, from science we know this, there is no known law of nature, no known process, and no known sequence of events which can cause information to originate by itself in matter. So both of these agree there's no way this can happen by chance. So then in conclusion, life consists of mass and energy, that's material, and information, which is non-material. So life requires information that's stored in the DNA, and machines, the storage and programming. I showed you those parts, and then programs. Why are programs needed? They're needed for replication, for reproduction of life, and they are complex. They are, because it requires irreducible complexity. All parts need to be there, and it needs to be specified, not random, but specified for meaning. And life requires a design, and therefore a designer. So life from non-life doesn't happen by chance. Information is the basis for life, and information requires an intelligent mind. And we believe that designer and creator is God. So here we, again, thanks for the your attention to this. life is very complex, but you can see that life requires information. Information is the basis for life, and that information requires an intelligent mind. No information comes without a designer, without an